Welcome to the module. Introduction to Blockchain Technology. Let us begin. After completing this module, you will be able to define blockchain technology, describe how blockchain technology works, describe use cases that suggest the significance of blockchain technology, and identify characteristics that make blockchain technology a disruptive innovation. Now that you know the objectives, let's begin with the training. Click Next to continue. Blockchain is a database on a network or platform. It is a programmable technology for securely transmitting, sharing, adding, and validating transactions, similar to that in a ledger. Blockchain works on distributed ledger technology that records the transactions. The distributed ledger can be distributed across many locations or nodes, hence, it is called distributed ledger. Blockchain is distributed in the sense that the ledger is not held in a central location but spread across a network of computers, and it is transparent such that every transaction is made public for all to see. Data is considered a block, and constantly growing databases are added to this ledger as blocks. Several such blocks after being validated and approved are added to the network, which is considered a chain formation. Instead of chunks of data being shared between people, all required parties in the network have access to this ledger. The distributed ledger can be shared across many locations or nodes. Full nodes contain a complete copy of the blockchain. We now have a basic understanding of blockchain technology. Click colored text to learn more. It is the transfer, exchange, or sharing of data between two or more individuals. Data can be pieces of information, value, money, and so forth. Transactions can take place on the same or diverse online networks and/or platforms or between people. Click X to exit. A traditional ledger is a record-keeping system for transactions. It is centralized, or owned by a group, and its methods of data entry may vary. Changes to or the reordering of entries can occur without the consultation of stakeholders. It may not hold an auditable trail or is often corruptible. Click X to exit. The distributed ledger acts as a record of consensus of validation. Consensus mechanism is an approach whereby all the parties in the network validate and approve the transaction. This helps to maintain each version of the ledger in synchronization with the rest. This mechanism also ensures transparency in the operational process, hence, the distributed ledger acts as a record of consensus of validation. Click each icon to learn more. Data can be added by multiple parties in a network. No one can delete or edit the data in isolation. This technique, which is used to safeguard data from getting tampered or duplicated, is known as cryptography. All those in the network validate the transactions and ensure that all changes in the transactions are auditable. This eliminates the need for third-party authorities maintaining or monitoring transactions at extra cost and time. Cryptography is the differentiating factor in blockchain technology. Click each step to learn more. Hashing. A method to verify that the message is not tampered with. It is equivalent to the wax seal on an envelope. If it is broken, then you know the message was tampered with. Encryption, a method to obfuscate the contents of the message. Obfuscation is equivalent to altering the contents of a letter to such a degree that only someone who has the decryption key can read it, for example, a password. Examples of encryption include storing a message, data, or value in a QR code or a barcode. Digital signature. A method to verify that the expected sender of the message was the actual sender. Sender verification is equivalent to a signature on a check or document. It is a way to ensure that a particular sender sent the message. A digital signature is a mathematical scheme representing the authenticity of a digital message or a document. Let us see a couple of examples or the use cases of this technology. Blockchain technology solves the problem of trust. Let's take a look at a scenario. 1. Lucy wants to send money to Kevin. 2. The first block that is created represents the transaction. 3. The block is broadcasted to all in the network. 4. Those in the network approve and validate the transaction. A consensus approach is used to authenticate facts. 5. The block is then added to the network. The system is easily scalable to several participants. 6. Kevin receives the money, without the need for intermediaries is eliminated. Click Next to continue. Let us see another example or use case of blockchain technology. In the current scenario, a patient receives medical care, which often requires to bring paper documentation and/or provide authorization for access between providers. This healthcare data can be securely stored, mutualized, and shared by supporting it with blockchain technology. The following characteristics make blockchain technology a game changer. Click each colored tab to learn more. In this module, we learn to define blockchain technology, describe how blockchain technology works, describe use case that suggests the significance of blockchain technology, and identify characteristics that make blockchain technology a disruptive innovation. This brings us to the end of this module. Click Next to continue. This is a sample e-learning asset for demo purpose only. For more details, email us at info@slate2screen.com. Happy learning. Click Exit to end the course.